Last video I have started with the geometrical representation of the zeros of polynomial, and I have started with the linear polynomial. Now today I am going to continue and see how we will plot the zeros. We will find the zeros from the graph. So as I have concluded the last video by saying that the zero of polynomial is nothing but when the value of y is equal to 0. So y is equal to 0 implies that x-axis, the point where the point of the graph, the point of the plot which touches the x-axis, that is called as a 0. So now for a polynomial equation of a quadratic form, that is degree 2, let us consider the case. So p of x is equal to ax square plus bx plus c. This is a quadratic equation and quadratic polynomial. So let y is equal to p of x, y is equal to ax square plus bx plus c. So since it is difficult to plot the polynomial, let us consider that we already know that how a polynomial of quadratic form appears when plotted. So for example, there are three cases. Case 1. Generally, if you see the zero of polynomial is given by minus of b plus or minus root of b square minus 4ac by 2a. This is a solution for quadratic equation. So don't get scared by seeing that a big equation. That is of not needed, but I have given it, which you will learn in quadratic equations chapter later on. So if anyone interested to find the zeros of a particular quadratic polynomial, then you can use this equation directly, blindly substitute the values of a, b, c in that and find out. So now I am not going to do that. I am jumping into directly three cases arise when we are plotting the polynomial, quadratic polynomial. So case 1 is when generally what happens is that the quadratic equation is of form. If I plot, it will be graph is of parabolic form. It will be like this. I mean this will be upper parabola. It's like a U shape, you can say. So or downward parabola depending on the value of a. This will be upper parabola when it is a greater than 0. So this is a downward direction when a value is less than 0. This value, this a, is constant. So in these two cases, we are going to see there are three cases arises. That is case 1. Case 1 when the quadratic polynomial actually touches two different points on the x-axis. So these points, these are the zeros. So this is the case 1, and also there is another case. So this case there are two zeros for these two polynomials, quadratic polynomials. There are two zeros. This 0 is let us call it as alpha beta. For example, there are two zeros, alpha beta. So these two zeros are different, but depending on the value of a, this type of graphs may come. So case 2, if I take, what if alpha is equal to beta, that two zeros are equal, that is we get a case 2 like this. This only touches only one point on the x-axis. So in case 1 we saw that there are two zeros for this quadratic polynomial, and this is a case 2. This is a downward parabola. It also touches only one point on x-axis. So this has only one zero. As we have seen that a quadratic polynomial can have two zeros, not more than two zeros, but there are cases where it can have two zeros, 1 0 and 0 0 also. We'll see that case, but this is a case 2. Here there is only 1 0, there is only single zero, that is this parabola is intersecting the x-axis only once. Even though it is a quadratic equation, only it is intersecting once. So this implies that there is only 1 0, or 1 0, or there can be other case like alpha is equal to beta when both the zeros are at same position. This also is possible. This is also possible. So if I take for example, this is 2, so x minus 2 into, wait, so suppose 0 is at 2, so x is 2, x equal to 2 is a 0. So from the linear interpolating slightly, we will manage it, bring it to that left hand side, x minus 2 is equal to 0. So if another 0 is there at again x at 2, x equal to 2, then this equation becomes x minus 2 into x minus 2 will give you the quadratic equation of this form. So this implies that x minus 2 whole square, x square minus 2 into, if a minus b whole square is equal to a square plus b square minus 2ab. So if I use this identity, this is needed, and also coming to identities, this identity is needed, and also one more identity I will straight away state it. A plus b whole square is equal to a square plus b square plus 2ab. So if I use this result, then I will get x square minus 8x plus 4. So this is a equation which has this graph. So I can consider it that it touches at x equal to 2 two times. 2 times implies that same point. But if I take a case 3, there are two cases, remember, case 2, in case 2 there are two possibilities. There is only one time the graph is touching, but it implies that there is only 1 0, or there can be two equal zeros. So case 3 will be as follows. So as you can see that the parabola is not even touching the x-axis. This implies that there are no zeros for this quadratic equation. So there are no zeros, zeros. There are no zeros at all. So there are three cases, which implies that for a quadratic equation there can be two zeros, at max two zeros, or either 1 0 or 0. Only there are totally no zeros. So these are the three cases for a quadratic polynomial. Similarly, for any polynomial, now I will take a random graph of a polynomial. Say it is like this. This is perhaps a cubic one. I can assume that it is a cubic because there are 3 points it is touching. So this graph will have degree greater than or equal to 3. It should be cubic. Yes, cubic or more than 3 degrees. So I will consider it as x cube. So cubic equation. So there are 3 zeros for this polynomial graph. Similarly, if I plot another polynomial, so this graph is a weird one, but you can see we can easily find the number of zeros 1 2 3 4 5. So there are totally 5 zeros for this polynomial. So totally 5 zeros. So this should be of degree 5 or greater, degree 5, at least degree 5, remember that. So this is what is a geometrical interpretation of the zeros of the polynomial. So why it is important is we can very clearly predict the zeros by seeing the graph itself, that how many zeros are there and what kind of polynomial it may be. So This is how this topic ends here. I'm going to continue with the relation between coefficients and also other topics like remainder theorem, factor, and division of polynomials in the upcoming videos. Thank you.